Okay, for this part of the topic we're going to be looking at the Haber process, and we're going to be looking at how we make ammonia. Now, ammonia is such an important product as it's used in lots of different products. For instance, 80% of the ammonia that's made is actually used in fertilisers, and fertilisers obviously are important for helping plants to grow. You've also got ammonia can be used in making nylon or making nitric acid, for instance. And these are some of the things you may be asked in an exam question, the uses of ammonia, and the main one is for making fertilisers. Now, the chap who invented this process is called Fritz Haber, which is why it's called the Haber process. And he discovered this this brilliant reaction where you take nitrogen and hydrogen and you put them together in a reactor. You use a catalyst, you have a high temperature and pressure, and by doing that you then make ammonia. And the brilliant thing about the whole process is that any nitrogen or hydrogen that's left over can be sent back to the beginning and it goes through the process again. Now, Fritz Haber was a German chemist who invented the process. He received the 1918 Nobel Prize in Chemistry for his work. He also helped to develop the use of chlorine and other poisonous gases used during World War I. So interesting that he won a Nobel Prize. Okay, so let's have a look then. As you can see in the top left there, you've got the word equation for nitrogen and hydrogen to make ammonia. And if you see that little arrow that points both ways, now in a normal reaction, when we're looking in science, it just points one way to show a reaction taking place. Where it's got a backwards and forwards arrow like that, it means it's a reversible reaction, meaning it can be taken, ammonia can be taken back down to nitrogen and hydrogen. So you must make sure you can explain that in an exam question. Okay, so looking at the Haber process, you obviously have to, when you're making new substances, you have to consider different things, like for instance the price of the energy, how much energy you're putting into a process. Is it going to be worth making that product? How much labour is involved? How many people do you need to employ? How quickly can it be made? How much do the reactants cost in the first place, or the cost of the equipment? These are factors you need to consider. Also, when it comes to the Haber process, you actually need to have a high pressure, usually around 200 atmospheres. Now, obviously, the more pressure you create in the reactor, the higher the cost. Also, the temperature. The temperature, in order to gain as much yield, and that's the amount of ammonia that you make, needs to be around 450 degrees. You must remember that number. So you've got a high pressure of 200 atmospheres, a temperature of 450 degrees. And this is because that is the temperature that produces the most yield in the quickest time, and also is the most cost efficient. The last thing you need is an ion catalyst, and if you remember, catalysts increase the rate of a reaction, but again that's something that has to be bought and has to be factored in to the process. Thinking about the number of people required to operate the machinery and the recycling of the unreacted reactants. But again, like I said, this is a good thing in this case, because anything that's left over just gets sent straight back to the beginning, and that goes back into the reaction. So in summary, I'm going to say again, because you really need to learn these conditions, the Haber process requires an ion catalyst, it requires 200 atmospheres of pressure and a temperature of 450 degrees. This comes up all the time where they ask you to name the conditions you need for the Haber process to work. It'll either be that, or they'll put a little graph that you can see in the bottom left hand corner, and they'll ask you to describe what's going on in that graph. So make sure you look at it very carefully. Okay, so that graph in particular then, the higher pressure does give a higher percentage yield, but it makes it expensive to make and maintain the reaction chamber, and that's why you need to have a lower pressure. The catalyst increases the rate of reaction but doesn't affect the yield, again reducing costs, but has to be initially bought. So you can see we're starting to look at, it's not just about the process, it's about all the other factors as well. The effect of the temperature. The high temperature speeds up the rate of the reaction and the ammonia is made faster, but it reduces the percentage yield of ammonia, so it is made at a slower rate at a lower temperature. Okay, now you can see the symbol equation has just popped up at the top. N2 plus 3H2, the reaction takes place and you make 2NH3. Please make sure you learn that, because again that is another common question where they actually ask you to write out that equation, and you really do need to know. So N2, 3H2, reaction takes place, 2NH3, and that's the Haber process.